All right, after making that table support for my drill press, I wanted to check a run out on my drill check, the chuck and the arbor. And I wished I had filmed it because this is the second time I've done it, but the first time I did it, I had 20 thousandths run out when I had before I took it apart. Let's just put it that way, before I took it apart. So coming from the factory, I had 20 thousandths run out at the chuck right here. You can't see that. I'm at this point right here, going around this. Then I also chucked in a piece of steel, and I also had run out of that same amount with the steel chucked in the round bar chucked up in the chuck itself. So I'm going to put this back together, but I wanted to explain a few things before I did that. This is a Morse taper, and they call it Jacobs chuck taper. So JT, Jacobs taper 3 is what this chuck is. And so that matches the shaft over here, which is this end here is a Jacobs taper 3, and that fits inside the chuck here into this taper. So it's real easy to take apart. You knock it out of the drill press, and then you punch the shaft out this way from the chuck. So I've done that, but what I'm going to do right now then is I'm going to put this back together and show you hopefully the results I get. Just by taking it apart, cleaning it up a little bit, and reassembling it, I was able to take away about half that run out. I got it down to just a little under 10 thousandths, which is pretty good for a drill press, I think. But I'm going to even take it one step farther. I ordered, because this is a foreign made chuck, I ordered an actual Jacobs chuck and a new arbor here to see if I can do better than that. So this is a number 4 Morse taper, which fits up into the drill press, and these are both just nothing more than wedged fits. That's it, friction fits. So let me put it back together and show you what I have and how I'm checking this. Just got some WD-40 on some paper towel here. I'm just cleaning out the outside of this quill. So you see this slot here. That's what you use to knock out the arbor shaft. You use it with this wedge pin that comes with most drill presses of this type anyway, but you could knock it out with any type of wedge, I guess, just as long as you can get it in there. So this becomes the part that keeps it from spinning. So this just goes up into the quill, and incidentally, I've taken the time to, clean this all out, make sure that I got all the grime out of there. And I didn't use WD-40 in there. I used like a degreaser, naphtha, or any good degreeser, I guess, CRC degreaser, something that'll clean and dry. So you can see how that comes up in there. You have to get this tang lined up with that opening, and you put it up in there, and that's it. Just give it a little tap. So I've got the adjustment screw down here, and I'm going to put that up now. Or I'm going to drop that down here so I can raise the quill up. And then you just give it a little tap. It doesn't take much. That's it. That's set. That's not gonna come out unless you get back in there and knock it out. So let me. I've got my dial indicator set up here. Let me get things rearranged, and I'll show you how I'm checking runout on this part of the shaft right here. So let me rearrange things here. Okay, I've got my dial indicator attached to this bar, which is clamped down with this Festool quick clamp to this piece of extrusion, and then that is going to be clamped tight to my table once I get it in position, just to keep it from moving. If you were doing this on a cast iron top, you could use a magnetic base. I don't have a magnetic base, so I'd have to do it this way anyway. You just got to immobilize the indicator to keep it from moving. So I'm going to bring down the quill again and try and get it centered on the indicator, and then we'll just check the run out and see what we have for that. If you get tired of spinning that nut up and down, you can just make yourself a wooden block like this. This is about 4.5 inches, I guess, and just set it in there and wedge it. It'll work just the same as having that nut down. Okay, so I'm going to slide this up, put it on that taper. I'm going to lock this into position here close anyway. Something like that. And I'm just going to move it back and forth to make sure I get the high spot. That's low. That's low. Let's say right about right there. That's should be about dead center right there. Looking at it, it looks good. Yeah. So I'm going to call that dead center. And I'm going to zero out my indicator. I'm going to lift the top. You can't see this, but I'm opening up the top. I'm not going to spin this by grabbing the shaft here. I'm going to spin it by grabbing a hold of the pulley and spinning it here. Okay, so I don't want to put any deflection into this with my hand. I'm going to try and do it up here, nice and easy. So let me get the indicator in the shot here and show you what kind of a movement I have. Okay, if I've got this set, if the indicator is set properly on, and it's basically dead center of the Jacob's taper, we should, if it's perfectly seated, we should see no movement on that, you know, but let's just see what happens when I turn this. I'm a little below. What is that? That's about 2. And that's about 2 minus 2. So let's just see if we can find the high spot here. Let's just say there. I'm gonna right there. Set that to 0 and see if we spin it, what we get this, if we get 4. We even we're getting 5 there. That's pretty bad actually compared to what I did have. I had 2. Well, now it's not going back to 0. Right there. I guess it is going back to 0. That's pretty close. Let's see, that's my high spot. Yeah, we're at 4. So 4 thousandths. So what I'm going to do is I'm going to knock this out again, turn it 180 degrees and reseat it, and see what kind of reading we get with that. You know, there's only 2 positions you can put it in. This one, or rotate it 180 degrees and put it in the other way. Let me get that out and we'll try it. All right, reseated 180 degrees. Got my caliper dial indicator set to 0. And it looks like by doing that, we picked up, let's just say right there. We got 2, maybe 3 thousandths there. So that's pretty good. Now I read somewhere this is when it's going to 3 this way, it's moving towards the indicator. So that means that this is that means that the arbor is, the high spot is towards the indicator by 3 thousandths. If I put it back to 0, I've read somewhere that if you take and just, you know, you whack it up in there, but if you take a rubber mallet, I'm going to zoom out here a little bit, and you tap this side, which is which needs to come, this side needs to come this way a little bit, that you can sometimes pick up and straighten it out basically in this taper. So I'm going to try that. I'm going to tap it. What I'm going to do though is I'm going to pull my indicator away, and I'm just going to tap it on this side a couple of times. And let's just see what we get. No, we didn't get anything. Oh, wait a minute. There's 0 now. I'm gonna get my cheaters on here again. I'll zoom back in on the indicator. Okay, so there's 0. After tapping it, let's see what we get here. Let's say maybe we picked up a little bit, not a lot. So we're going to call that good. 3 thousandths. Not too bad, I don't think. But now I'm going to put the chuck on here, and we're going to check that. Same thing, just put it there, give it a little push up. Make sure your jaws are all the way in. And then just a couple of little love taps here. And that's all it takes. That thing is seated. Okay, let me get the indicator set up and we'll take some readings here. All right, I turned my drill press light off. This is actually, I think it's going to be better, easier to read. I've got it set at 0, and now I'm going to spin it 1 full revolution here. And you can see I've got about the same amount. I'm actually pretty impressed with that. That's not bad, 4 thousandths. Just by taking it apart, cleaning it up and putting it back together again. And I'm not kidding you, the first time I checked it, I had about 20 thousandths run out there. So that is really good. I'll take that. It might even make me cancel my order. I like that, 4 thousandths, not bad. There's the high point, maybe 4.5. Yeah, not bad. Okay, the next test then is to put a bit in the chuck and see what how that translates. You know, as far as run out. So the holding power or the parallel part of the jaws, to see if they're truly parallel to the chuck, and see what kind of reading we get with that. So let me run that test. All right, I found the straightest thing that I have is one of these transfer punches. I've got the largest diameter one in there. I believe it's a 1/2 inch. Let me just take a quick look here. It's 20. It's 17/32. It's just over a half. But anyway, I've got it. I've got the indicator in the middle of the shaft vertically, and also top dead center. So let's see what happens when we spin this. Well, that's not bad. You know, I don't know how round that is, but I'm going to put this at 0. I'm going to say, yeah, that's 0. I'm going to say we have 3 thousandths. Now that's the middle. I'm going to reset my indicator. I'm going to take the block of wood out and I'm going to drop it down and get down to the end. Let me see if I can show you what I'm talking about here. You can see where I'm set up here now. I'm in the middle of the shaft, or the drift punch, and then you can see the movement of the needle, hopefully, and it's about 3 thousandths. I got to get that. There's 0. Yeah, 3 thousandths in the middle. So I want to take a reading down here at the end and see what that says as well. So I want to reset my indicator up and drop it down, and I'll come back. Okay, got things reconfigured. Got it set at what I think is top dead center there, and we'll spin it. And down here, I've got, looks like about 5. I gotta go around the other side here. 6. Six thousandths. Yeah, there's 0. Actually, I get up to about, yeah, that's 6. Well, like I say, I don't know how straight that is, but for what I'm doing, that's the closest thing I can come up with that doesn't have any dips or valleys in it, as just a round piece of steel. So, is that acceptable? I'd say for me it is. The true test is just doing this sometimes, taking that away and just turning it on. Boy, that is so much better. Wow. I'm going to put a bit in there and run a couple of test holes and see what happens. I never expected these results, to be honest with you. I'm extremely happy with the way it's set up now compared to what I had before. So now my table is nice and rigid. This is running truer than it ever has. I still have that Jacob's chuck and that new Arbor coming. I'm gonna install those and check it again, and then I can use this as a pin vise, just a handheld drill bit. So it's not like I'm gonna throw it away, And after I run it, I'll see what happens. I might just return that other setup. We'll see. Let me get a drill bit here. Okay. This is a drill bit set I've had since, I couldn't tell you when, my mid-20s. So I took the 1/2-inch bit out of here. I've had this 1/2-inch bit that long as well, and you can see here the top of it's been spun, and so I took and filed off some burrs, but we'll see how it chucks up into this drill press here and what kind of a hole we get with it. See how it spins, I guess. Now I generally don't drill holes in wood with a high-speed bit like this, but I want to try this first anyway, just to see it. And the other thing about this is I've resharpened this, so I don't even know if this point, where it comes together here is even dead center, but we'll find out how it works. Let's just see how it spins. That's not bad. And then here's kind of the true test. Just let your wood float, and as the bit comes in contact with the wood, see if it wiggles around, I guess, a little bit. Let's just try it here. That. I'm not holding that a bit, and it's staying pretty true. Again, pleasantly surprised, and I guess I'm a little bit impressed with the way it's running now compared to what I was doing before. Now, the drill press table, like I said, it's been reinforced, and that's good and solid, so that could be part of it as well. But I like that I wasn't getting those kinds of results before I did any of this. So I'm going to try a Forstner bit next and see how that works. All right, 2 more bits I'm going to try. This is a Ryobi. It's from a set I have that sits on the back of my drill press there. Ryobi 8-piece. It's their, what do they call it? Their patented X-wing design. So that's this bit. They have about a 3-inch shaft at them, 3-inch shaft on them. But the other unique thing about them is they have a triangular connection shaft here instead of it being round. So that's one thing unique about that. This is just a Forstner bit from a cheap Chinese set I bought a long time ago. It's a 2-inch, and it's also got a, that's 2 7/8 shaft, but it's turned down to what does that turn down to? 3/8. Yeah. Yeah, so you could use this in most, you know, cordless drills if you had to. So let's try the Ryobi first with the triangle connection here. We'll see how this sets up. I want to make sure that I get those, you know, on the jaws like that. And I'm going to let this float again like I did the last time. And let's see what kind of results we get with this one. A little more movement there. Not bad though. Not bad at all. I'm going to close the cover here. Okay. All right, let's try the 2-inch and see what happens. I'm liking the results I'm getting, I'll tell you that. Much better than what I was having before. Let me clean this up. We'll try it right about there. That's not moving at all. It wants to rotate, but it's not dancing all over the place. It's a nice clean hole. I guess that ends my experiment. I'm telling you that taking a little time to clean it up, put it back together, and checking it has worked wonders on this drill press. It's far and above the tool I bought and had set up right from the factory. I literally did nothing to it, and I had all kinds of wobble and shake. You've seen in some of my videos the way things dance around. Now, like I said, I've reinforced the table, but that has done wonders for the way I'm going to be able to drill holes from now on. So, thanks for watching, fellas. See ya. And gals, I guess if there's some gals out there, but thanks for watching anyway. See ya.